The t-test is one of the most popular and the most commonly used statistical tests. The t-test is used for any time you have two different groups and you want to test for the difference between the means of those two groups. They can be different individuals, so this can be a group of Americans and this is a group of Chinese people, or they can be the same people before and after some treatment or some intervention. If we go back to the example I gave a few videos ago about seeing whether people are gaining weight when they're stuck at home eating ice cream and watching Netflix, this might be their weight before they start eating ice cream and watching Netflix, and this would be the weight after 2 months of lockdown. So there's different variants of the t-test. I'll talk about that more in a few minutes. But the idea is that you have a collection of data points in this bin and a collection of data points in this bin, and you want to test whether the average of this bin is different from the average of that bin. That is the alternative hypothesis. You can probably already imagine what the null hypothesis here is, and that is that the means of the two groups are the same. So if the null hypothesis were true, we could actually mix up all the data into this bin and this bin, and it wouldn't actually matter because the means of all the data points are the same. Now I'd like to show you the basic formula, the basic mathematical equation underlying the t-test or the t-statistic. It's a ratio, so it has a numerator and a denominator. Now don't worry too much about what each of these individual terms mean. The point is that the numerator is the difference of the means between the two groups, and the denominator is some measure of standard deviation or variability or the dispersion of the data within the groups. Now the reason why I'm talking about this in kind of vague terms is that there are several different variants of the t-test, and the different variants are used for different specific circumstances. The formulas will all look slightly different for the different versions of the t-test, but none of that matters. All of the t-tests work exactly the same way in the fundamental approach to generating this t-statistic, and that is coming up with a ratio of the difference of the means divided by something about the dispersion or the variability of the data. Now, the idea of the t-test is that when this t-value, this ratio, is large enough, then the finding is statistically significant. So the difference of the means needs to be large, and the amount of variability in the data needs to be relatively small. And when you get those things, a large difference of the means and a small variability, this t-value is going to be large, and your finding will be statistically significant. Now, this is kind of like a basic formula for a simple implementation of the t-test. There are many different kinds of t-tests. They're all in this t-test family, and they all have slightly different formulas. They look generally the same, like what I showed in the previous slide, but the formula has to be adapted depending on the nature of the data, whether it's one sample or two samples, and if the samples are related to each other or if they're independent. These are non-parametric methods that you might use if you have outliers in your data. There's also permutation testing, which is an alternative way to derive p-values from the test. But none of this matters. The main point that I want you to understand in this video is that the t-test in general is testing for differences in the means or the averages between two groups of data. And the way that the test works is by comparing the means and dividing by the variances.